All right, today's date's on the board. In your notes, go ahead and put 24th of August. And this is properties of real numbers. That's how you need to label your notes. And all of you should have written this down. Natural numbers start at 1 and go on to infinity. Okay? That's why I have dot, dot, dot here. It goes on forever, starting at 1. Whole numbers are the same as the natural numbers, but they start at 0 and go all the way to infinity. Integers start at negative infinity, go to positive infinity. So that's why I have dot, dot, dot here and dot, dot, dot here. It goes on forever in both directions. Notice there are no decimals, no fractions in any of those. Your decimals, fractions will be contained in these two down here. Now if it's a fraction that works out evenly, for example, 14 over 2 is what? 7. So 7 would fall into natural, whole, integer, and rational. A rational number is any number that can be written as a fraction. The number 7 can be written as a fraction many different ways. We could say 14 over 2. The easiest way is to say 7 over 1. All of these numbers, natural, whole, and integers, are rational. Because all you have to do to make it a fraction is put a 1 underneath. Correct? All right, so examples of rational numbers, 3/4. If I ask you to classify what type of numbers 3/4 falls into, you would just say rational. What about -5? What? Integer and what else? Rational. Okay, so you got to list them all. You don't have to list real. All of these are real numbers because these are properties of real numbers. So these are the ones you need to list. Any questions about rational numbers? Yes.
Is there such thing as a non-real number?
Yes. We'll get into those imaginary numbers later on in the book. Okay. Irrational numbers are numbers that are not rational, so you can't write them as a fraction. The best examples right here, pi. Pi is a decimal that goes on forever, right? Pi is not just 3.14. That's an estimate. 3.14 is an estimate. 3.14 is actually rational. Pi, the number pi, is irrational because it's a decimal that goes on forever without following a pattern. So if you want to write that part down, decimals that go on forever without following a pattern are irrational. Decimals that follow a pattern or have a stopping point are rational. Like 3.14 is rational. Any square root that is not a perfect square is irrational. Okay? So if I said square root of 4, classify square root of 4, what would you say? What sets of numbers? Natural, whole, integer, and rational. And square root of 5 is irrational. Okay? Because it's not a perfect square. Square root of 4 is a perfect square 2 times, yes.
What's the difference between natural and whole numbers?
Whole includes 0. Natural starts at 1. That's the only difference. Okay? Integers include all the negatives. All right, moving on. Okay, write this down. Graph those three numbers on one number line. -3 halves, 1.7 repeating, and square root of 5. You will draw the number line. And what I need to see on your number line is the whole numbers that each of these falls in between. Alright? So don't just draw a blank number line. I need to see -2 and -1 in order for you to plot -3 halves. We know negative 3/2 is in between, right in the middle of negative 2 and negative 1. Now, you don't have to be perfect in middle. I'm not going to get out a ruler and make sure that it's exact. Over here with 1.7 repeating, you know it's closer to the 2 because of the 7, correct? And square root 5, with any radicals, you need to type it into your calculator. I believe square root 5 is approximately 2.3. If y'all want to check me on that, you can. If it's 2.3, it would be closer to the 2. So just plot it closer to the 2. Now this one's pretty easy to estimate, so make sure you get these two correct. Because if you put it over here to the 3, then it would be obvious that you didn't type in or figure out what the square root of 5 is. All right. Yes?
What is it, what do you mean when it has, does that mean anything with that little line over the 7?
Yeah, that's repeating.
Or-
So that goes on forever. It's a repeating decimal. So what type of number would that be?
Irrational.
Rational.
Oh, rational.
Rational. Because it follows a pattern. Even though it goes on forever, it's following a pattern. All right, next. Compare those two radicals. Negative square root of 0.25 and negative square root of 0.01 using less than and greater than symbols. What I did here is get a decimal value for it. So just type into your calculator square root of 0.25 and you get 0.5. Square root of 0.01 is 0.1. Right? And then it's obvious that the left is less than the right. Now don't leave your answer like that. You have to use the original sets of numbers. And here's our answer. All right. Moving on. Okay, go ahead and write these definitions down. We'll talk through them as you're writing. The underlined words are your definitions. Opposite and additive inverse are the same thing. The opposite or additive inverse of a number A is negative A. So what is the opposite of the number 5?
Negative 5.
Negative 5. What's the opposite of negative 7?
7.
7. Very good. The sum of all opposites is always 0. That's how you can check your work. Next definition. The reciprocal or multiplicative inverse, same thing, just different word, of a number A is 1 over A. So all you do is flip it. Reciprocals. Most of y'all are familiar with reciprocals. If we had a 1 under the A, which you could have, then when you flip it, it becomes 1 over A. The product of reciprocals is always 1. If I multiply A times 1 over A, the A's divide out, and you're left with 1, or 1 over 1. Okay? Questions? We need to, we can come back to this. Looking at this example, find the opposite and reciprocal of those two numbers. Negative 3.2 and 3/5. Opposite is pretty simple. You just change the sign. So the opposite of negative 3.2 is 3.2. The opposite of 3/5 is
Negative 3/5.
negative 3/5. Okay. Reciprocal of this one is pretty simple. The reciprocal of 3/5 is what?
5/3.
5/3, all right? Now, over here, I don't want you just flipping a decimal, because we can't have a decimal within a fraction. So what I did, I converted this decimal to a fraction. So -3.2 is the same thing as -3 2/10. I reduced 2/10 to 1/5. Then I changed it to a improper fraction, -16/5. So -3.2 is the same thing as -16/5. Decimal fraction. Then I took the reciprocal of this to get my final answer. -5/16 is the reciprocal of -3.2. All right. For right now, if you have a radical, if I had square root 7, what's this reciprocal?
1 over the square root.
1 over square root 7. For now, we'll let you leave it like that. But you probably remember in the past that it's not simplified if we have a radical in the denominator, which gets into rationalizing denominators, which we're not going to worry about right now. We'll worry about that later. So if you leave it like this, you'll be fine. Okay? Only time you have to change something is when you have decimals. All right, let's talk through this as you write it down. And again, we'll come back to it if we need to. Properties of real numbers. You've all seen this. We'll pretty much go over it at the beginning of every math course. The closure property of addition is saying, and remember, this is properties of real numbers. Closure property of addition is saying if I add two real numbers, the result is going to be a real number. If I multiply, so this column is addition property, this column is the multiplication property. If I multiply two real numbers, the result is a real number. The commutative property of addition says it doesn't matter what order you add things in. 3 plus 4 is the same as 4 plus 3, correct? Both of them are? Both of them are? 7.
I didn't hear you
3
say.
plus 4 and 4 plus 3. Okay. Same with multiplication. 3 times 4 and 4 times 3 are both 12. Now the associative puts a third number in there, a plus b plus c. When I add a and b first, it's going to give me the same result over here that it would if I added b and c first. So 3 plus 4 plus 5, if I do 3 plus 4 first, I would get the same result as that I would if I did 4 plus 5 first. Same thing here. I multiply 3 times 4 and 4 times 5, then you'll get the same result. The identity property means I have to end up with the same number I start with. So if I'm starting with the number A, what do I have to add to A to end up with A? 0. Okay. Same thing over in multiplication. What do I have to multiply to A to end up with A? 1. Right? All right. The inverse property of addition means you have to end up with 0. So what do I have to add to A to end up with 0? Negative. All right. Here I have to end up with 1. So what do I have to multiply to A? Its reciprocal, which is 1 over A. And the last property combines addition and multiplication. Distributive. A times B plus C. Distribute the A. So you end up with AB plus AC when I multiply that out. example, identify the properties here. First one, 6 plus a negative 6 equals 0. Should be showing the inverse property of addition. The second one is a little tricky, because it throws a step in there trying to throw you off a little bit. Negative 4 times 1 in parentheses minus 2 equals negative 4 minus 2. So basically, you can ignore the minus 2 on both sides. Then you might see the property better. It's asking you how do you go from here to here. How do you go from negative 4 times 1 equals negative 4? And that would be the identity property of multiplication. Because you're ending up with what you started with. You start with negative 4, you end up with negative 4 by multiplying by 1. Okay? Definition. Absolute value. Absolute value of a number is the distance that number is from 0. Distance can never be what?
0.
Yeah. Yeah, you could have a 0 distance, okay? You're just not going anywhere.
Negative.
Negative, right. You can't have a negative distance. So, that's why absolute value is always going to be positive. Absolute value of a number is the distance that number is from 0. So examples below, and that's the symbol for absolute value if you haven't seen it before. 2 vertical lines around the number. The absolute value of negative 4 is, how far is negative 4 from 0? 4 units. How far is 0 from 0? 0 units. And now if you have some steps to do, you would treat absolute value symbols just like you treat any grouping symbols. You do everything inside, simplify everything inside first, and then find the absolute value. So the product of negative 1 and negative 2 is positive 2. What's the absolute value of positive 2? 2. Now don't make the mistake of stopping right here. Okay, you have to get rid of those symbols. And down here, what's the first thing I'm going to do here is find the absolute value of negative 5, which is 5. And then you multiply by a negative 1 to get negative 5. Okay?